Hello all, I am Rajshekhar from Sunrise Institute of Education. Today I would like to share one simple fundamental topic related to chemistry, that is valency. What is the valency? What is the importance of valency to writing of chemical compounds or chemical formulas in chemistry? Okay, this is very important and fundamental topic. Okay, let us see. Suppose for example, let us say sodium chloride. Sodium chloride. Generally, sodium chloride formula is what? NaCl. Sodium chloride. This is formula is NaCl. This is also written as this is in this way. This is nothing but here the sodium element is represented by Na. Chlorine element is represented by Cl. Here, one sodium atom can bind with one chlorine atom. At the same way, the chlorine atom can bind with one sodium atom. That is nothing but here sodium valency is 1, chlorine valency is also 1. Let us see second example, magnesium chloride. What is the formula of magnesium chloride? MgCl2. This is the formula of magnesium chloride. Here, let us see, one magnesium atom can bind with two chlorine atoms. Two chlorine atom can bind with one magnesium atom. Let us see. Here, one magnesium atom is attached with two chlorine atoms. Two chlorine atoms can attach with one magnesium atom. Okay. Here, magnesium valency is 2, chlorine valency is 1, 1. Okay. Let us take another example, aluminum chloride. This is aluminum chloride formula. Here in this aluminum chloride formula, one aluminum atom can bind with three chlorine atoms. Okay. In same situation, three chlorine atoms can bind with only one aluminum atom. Let us see. One aluminum atom can bind with here three chlorine atoms. In same way, three chlorine atoms can bind with one aluminum atom. Here, aluminum valency is said to be 3. Each chlorine valency is 1, 1, 1. Here, let us see what is the definition of this valency. Okay, let us see. Valency is nothing but combining capacity of an element. Valency is nothing but combining capacity of an element or an element capable to form how many bonds? It is nothing but its binding capacity. Okay, this is the definition of valency. Generally, in this periodic table, it consisting of more than 108 elements. How we find out a particular element has a particular valency? Okay, one shortcut method is there, a simple rule is there. Okay, by the knowing of systematic arrangement of periodic table elements, we can find in easy way of different elements valency. Suppose for example, all the first year group elements. Generally, suppose for example, let us say what is the brief outlook about the periodic table. The knowledge about periodic table plays very important role to remember their valencies. Suppose for example, here let us see sodium chloride. Here, what is the formula of sodium chloride? NaCl. Here, sodium is belongs to which group? First group. That's why sodium valency is 1. Okay, let us see magnesium chloride. Here, magnesium is belongs to which group? Second group. That's why magnesium atom can bind with two chlorine atoms. Likewise, same aluminum chloride. Here, aluminum is belongs to which group? Third group. Boron below aluminum. Boron, aluminum, gallium, indium, thallium. Here is also aluminum is present. That's why aluminum valence is 3. That's why aluminum atom can bind with 3 chlorine atoms. Is it right? That's why the group number is equals to its valency. Generally, I tell you one shortcut. Here in this periodic table, 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A groups is there. Okay, up to 4th A group, okay, their valency, the group number is equals to their valency number. That is nothing but all the first A group element shows monovalency. All the second A group element shows bivalency or divalency. All the third A group element shows trivalency. All the fourth A group element shows tetravalency. Up to fourth group, its valency is equals to its group number. That's fine. Next, what about remaining groups? Okay, after fourth group, okay, 8 minus corresponding group number. For example, what is the fifth group valency? Fifth group valency is equals to 8 minus 5 is equals to 3. Sixth group valency is equals to 8 minus 6, that is equals to 2. Seventh group elements common valence is equals to 8 minus 7, that is equals to 1. 8th A group elements, what about 8th A? 8th A group elements 8 minus 8 is equals to 0. Why? Because 8th A group elements already they have NST-NP6 configuration, that is nothing but octet configuration. Okay, generally let us see this tabular column gives the information about the what is the common valencies of different groups. Generally let us see all the first A group elements shows monovalency. All the second A group elements 2. All the third A group elements 3. All the fourth A group elements 4. This is the common valencies. Along with some of the elements also shows their another valencies also. Okay. Generally, let us see after fourth group, 8 minus corresponding group number. Suppose for example, let us say fifth group. 8 minus fifth group. 8 minus 5 is equals to 3. Next, what about sixth? 8 minus 6, 2. 7. 8 minus 7, 1. 8th group, 8 minus 8 is equal to 0. Okay. This is a brief information regarding to the valency. Okay. That's why to memorize different type of elements in periodic table, their valency, you must know the periodic table in a systematic way. That's why periodic table plays very important role.